All right, today we're going to be taking a look at the definition of inverse. So functions are considered inverses if and only if we use this symbol IFF, so you might see that in other classes. The f of g of x is equal to a positive 1x, and when you compose the functions g of f of x, so the other way, it equals a 1x. So they both have to be true. If one is true and the other is not, they are not inverses of each other. So we're going to do an example that goes through this. So these are inverses of each other, spoiler alert, but we're going to try to go through the process so you can see how to do it, and we should get a positive 1x both ways. So first thing we're going to do is f of g of x. Remember that if you prefer this notation, you can do this. So f of g of x is the same thing as writing it as fog of x, so it doesn't matter how you decide. F of g of x. So remember, I'm going to take my function g of x, so this x plus 4 over 2, and I'm going to replace that in for f of x. So everywhere I have an x in f of x, my outermost function, I'm going to substitute in my g of x, my innermost function. So instead of 2 times x minus 4, it's really 2 times g of x minus 4, which is x plus 4 over 2, and then minus 4. So from here, we just need to try to solve this. So we have 2 being multiplied to this fraction. Well, this is technically 2 over 1, right? So what happens when we have a 2 on the top, or the numerator, and a 2 in the bottom, or in the denominator? What is 2 over 2 going to give us? These are going to simplify to give us 1. So that's why this is a little bit easier. So we have 1, so those are taken out, so we have no more fractions. And so all I'm left with is this x plus 4 on the top in the parentheses, but then this minus 4 right after it. So what's going to happen when I have x plus 4 minus 4? Well, when I combine my like terms, that's going to give me 0. Therefore, f of g of x is equal to, because those cancel out, this positive 1x. All right, now that's just one part. Check. That's good. We also have to make sure that g of f of x is also equal to a positive 1x. So let's take a look at this one. So g of f of x. Let's see what this is. And again, you don't have to write goff x. You can write the other format. So g of f of x. I don't know why. I just kind of prefer that, I guess. But it doesn't really matter. So now my innermost and my outermost, my input and output, they have changed. They've flipped. So now my innermost function is f of x. So I'm going to take f of x, which is 2x minus 4, and I'm going to replace or substitute that everywhere I have an x in g of x. So instead of x plus 4 over 2, I'm going to have 2x minus 4 plus 4 over 2. So I'm going to replace x with 2x minus 4. Do you see that? So f of x is 2x minus 4. I'm going to take this and substitute my f of x function in everywhere I have an x and g of x. So instead of x, it's going to be 2x minus 4. These are the same. That's what that equals. So 2x minus 4, but don't forget this plus 4. So plus 4, and this is all being divided by 2. So do you see that? Instead of x plus 4, x is being replaced with 2x minus 4. So 2x minus 4 plus 4 all over 2. Let's deal with the numerator first. Combine like terms, I have this negative 4 and a positive 4 again. So what happens is I get this 2x, and that cancels out to 0 over 2. Well, again, what did we say? Anything divided by itself is going to be 1. So this gives us a positive 1x, and that's what we are looking for. So g of f of x does equal a 1x. And so because both of those are true, because f of g of x equals a positive 1x, and g of f of x equals a positive 1x, then we can say our original functions, f of x and g of x, are inverses of each other. Next, we're going to talk about how to graph these, and then we'll be able to see graphically that they are inverses as well.